Hi class, this video continues our study in chapter 1 talking about linear equations and linear functions by moving into section 1.3. And in section 1.3 we're going to talk about the slope of the line. So the first part of the lecture, what I'm going to do is talk about just in general what slope means so you can get a good idea of it. And then in the middle part of the lecture we're actually going to work a lot of problems, finding the slope of a line mathematically. And then finally, in the end of the lecture, we're going to talk about the slope of lines that are parallel to each other and the slope of lines that are perpendicular to each other. Okay, so first thing I want to talk about is comparing the steepness of two objects. All right, so suppose you have two ladders, and we'll call them ladder A and ladder B, leaning against a building. And notice how when they lead against the building, they both meet at the top of the point at 8 feet. Okay, so ladder B goes up to 8 feet, and ladder A goes up to 8 feet. All right, but notice how ladder B is only 2 feet from the wall, and ladder A is 4 feet. So how are we going to figure out which one is steeper? Okay, ladder A or ladder B? So we compare the vertical distance from the base, okay, of the building to the ladder's top with the horizontal distance from the ladder's foot to the building. So we're looking at, okay, well, this one rises 8 feet, but it's 2 feet here. This one, A, rises 8 feet, but it's 4 feet here. All right, so let's talk about when we compare those, what we get. All right, so the ratio of the vertical distance to the horizontal distance. So for ladder A, all right, the vertical distance here is 8 feet and its horizontal distance is 4 feet. So that means it has a ratio of 2 divided by 1 or 2 to 1, okay? Ladder B, on the other hand, has a vertical distance of 8 feet, okay? But now its horizontal distance is only 2 feet, all right? So its ratio is 4 to 1, all right? So it's a larger ratio. So since we see this larger ratio, what we say is that ladder B is steeper. Okay, like if you were to climb ladder B, you would notice it being a lot steeper than if you were to climb ladder A. Okay, so to compare the steepness of two objects, we compute the unit ratio. What a unit ratio means is there are no units to it, so they go away. They cancel each other out basically. Compute the unit ratio, you take the vertical distance divided by the horizontal distance of each object. Okay, so the object with the larger ratio in this case, all right, like the 4 to 1 compared to the 2 to 1, is the steeper object. All right, here's another example. All right, suppose you got two roads. Road A climbs steadily for 135 feet over a horizontal distance of 3,900. All right, so basically what this is saying is for road A, when you travel 39 feet, all right, you're going to rise 135 feet. Road B climbs steadily 120 feet over a horizontal distance of 3,175 feet. So for road B, you're going 3,175 feet and you're rising 120 feet. Which road is steeper? Okay, and explain your result. All right, so the sketches here are the two roads shown below. Note that this is important, the distances are not to scale. Okay. All right, so we want to calculate the unit ratio of the vertical distance to the horizontal distance of each road. So road A, vertical distance to horizontal distance, 135 feet divided by 3,900 feet gives you roughly 0.035 to 1. Vertical B, excuse me, road B is the vertical distance, the horizontal distance, 120 feet divided by 3,175 feet, you get 0.038. So notice here, all right, that actually, even though road B only goes up 120 feet, it's actually a little bit steeper than road A. Okay, that means as it climbs, the steepness of it is higher, all right, because the road B's ratio of vertical distance to horizontal distance is greater than road A. All right, so the grade of a road here, you've probably seen this on signs, is the ratio of the vertical distance to the horizontal distance. Right, this is written as a percentage for grades. We call that to write a decimal number as a percentage. We move the decimal point 2 places to the right, insert a percentage symbol. So in the previous example, looking back, move 2 to the right, so it go here and add a percentage. The grade of road A is 3.5%, and the grade of road B is 3.38%. Right, so obviously road B is the steeper road here because it has a higher grade. All right, so now I want to talk about the slope of a non-vertical line. Okay, so to find the slope of a line, all right, you're always going to need 2 points on the line, okay? So we call the first point x1 comma y1, and we call the second point x2 comma y2. So we're going to let these be two distinct points on a non-vertical line. Then the slope of the line, all right, which we use the letter M to designate the slope. And you've seen M actually in the previous example, or previous section, excuse me, when we talked about y is equal to mx plus b. Well, slope is just the vertical change over the horizontal change. Another way we describe this, or you might have remembered from previous math courses, is rise over run. So the vertical change, this is important, okay? You're going to take y2 minus y1, right? That's the rise. You're going to divide that by, because it's a ratio, of x2 minus x1. You cannot do it as y2 minus y1 divided by x1 minus x2. You cannot. The second point needs to be the first values here, and the first point needs to be the latter values here always. So just think of it as y2 minus y1 divided by x2 minus x1. All right, in words, the slope of a non-vertical line is equal to the ratio of the rise to the run, right? And going from one point on the line to another, basically. So if here's one point, here's the other point, here's the rise. Well, how much does it rise? It rises from y1 to y2, so that distance is literally y2 minus y1. And how much does it run? It's horizontal change. Well, it goes from x1 to x2. Well, that distance there is just x2 minus x1. That's where these points come from, or these values come from. All right. So a formula is an equation that contains two or more variables. So we refer to this equation, this y is equal to, or excuse me, this equation m is equal to y2 minus y1 divided by x2 minus x1 as the slope formula, right? So it's the formula you use to find the slope. So here we list the directions associated with the signs of the rise over run. Okay. So let me give you the sign of rise or run, right? When the run is positive, right, you're going to the right. When the run is negative, you're going to the left. When the rise is positive, you're going up. And when the rise is negative, you're going down, right? So remember those graphically as well over here on the right. All right, let's do some examples of using that slope formula. So I'm saying, look, I want to find the slope of this line. And this line, this is what I know about it. It contains the points 1, 2, and 5, 4. All right, well, using the slope formula, I'm going to have this one here, 1, 2, be the first point x1, y1. And the second one, this point 5, 4, be the second point x2, y2. All right, so we have the following. Slope is equal to y2 minus y1. So this is y2 minus y1, so 4 minus 2, divided by x2, which is 5, minus x1, which is 1, so divided by 5 minus 1. 4 minus 2 is 2, 5 minus 1 is 4. Well, 2/4 we know reduces to 1/2. So the slope of our line here is literally just 1/2 through those 2 points. All right, so by plotting these points, all right, we find that if the run is 4, then the rise is 2. So let me show you. When we plot the points 1, 2 and the point 5, 4, literally to go from 1, 2 over to 5, 4, I have to run 1, 2, 3, 4 points and then rise 2 points, right? Which is literally the same as our results we got from using the formula. Or if you want to think about it like this, well, you might be like, well, it's 1 divided by 2. Well, rise, or excuse me, run 2, 1, 2, rise 1. Run 2, rise 1. We get back there if we just do it twice now. All right, talking about increasing and decreasing. An increasing line has a positive slope, right? So this is an example of an increasing line that has a positive run and a positive rise. A decreasing line has a negative slope, right? So it's when one is negative and one is positive. So an example is when you have a positive run, but a negative rise. So it means it's falling like this. All right. We also talked about in previous sections that increasing goes up as you go to the right, decreasing goes down as you go to the left. So positive slope means you're going up as you go to the right. Negative slope means you're going down as you go to the right. All right, let's do a tricky one here. Right? So let's find the slope of a line that contains these points. Right? Notice how there's a lot of negatives in here. So one point is -9, -4, and another point is 12, -8. Excuse me. Okay. This right here is going to be our x1, y1, and this here is going to be our x2, y2. Right? So it's y2, negative 8, minus, and then I'm going to put in parentheses, y1, which is negative 4. x2, which is 12, minus x1, which is negative 9. I'm going to put that in parentheses. Notice you have negative, 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 negative. Double negative becomes a positive. So you have negative 8 plus 4 divided by 12 plus 9. Well, negative 8 plus 4 is negative 4. 12 plus 9 is just 21. Here you can pull the negative out in front, and what we're saying is we have a negative slope. So the slope is negative 4 21sts, or negative 4 divided by 12. What this means is the slope, the line, let me go back, slopes down like this. The line will look like this. Just be careful of these double negatives when you work these problems. I can't stress that enough. Always remember when you see two negatives in a row, it's going to become a positive. All right, so now I want to talk about comparing the slopes of two lines. Right? So looking at these two lines here, right? Find the slopes of the two lines sketched. So notice I don't even give you any points. I just say, hey, look, find the slope of these lines right here. And which line has the greater slope? All right, and explain why this makes sense in terms of the steepness of the line. All right, so when you're just given two lines like this, what you have to do is you have to pick the points, okay? So I want to calculate the slope. So here I'm just pulling the two lines apart. So I'm going to pick this point here, 3, 1, and this point up here, 4, 3. Well, to get to this point, notice I need to run 1 and then rise 2. So run 1, rise 2. So my slope of this green line, L1, going back, this one right here, is 2 over 1, or just 2. Looking at the other line, L2, picking that point 3, 1, to get to this point up here, the point 4, 5, I run 1, then rise 4. So the slope here is 4 divided by 1, or just 4. So it looks like L2 has the higher slope, so it is the steeper line. All right, so note that the slope of L2 is greater than the slope of L1, which is what you expect, all right, because just even looking at it, L2 is steeper than L1 there. All right, so in general, for two non-parallel lines, we'll get to parallel lines in a bit, the steeper line has the greater absolute value of the slope, right? So note the sign indicates the direction, meaning increasing or decreasing, yet the absolute value of the slope indicates the steepness. So like look at this green line here, right? It has slope -1, or -1/2, excuse me. Comparing it to this line right here, this one has slope 1. Right? How do you compare the negative and positive? Take their absolute value. The absolute value of this line, the slope is 1. Absolute value of this line, slope is 1/2. So this one here is the steeper line. All right, so the absolute value of the slope of a line measures the steepness of the line. The steeper the line, the larger the absolute value of the slope. All right, let's do another one. Let's take a look at a horizontal line. So find the slope of the line that contains the points 2, 3 and 6, 3. Well, let's let x1, y1 be 2, 3 and x2, y2 be this other one, 6, 3. So x1, y1, x2, y2. Plugging it in here, you get y2 minus y1. So 3 minus 3 is 0, divided by x2 minus x1, or 6 minus 2, which is 4. 0 divided by 4, that just gets me 0. So I'm saying the slope of this line has 0. Remember, it's rise over run. So just even looking at this line, does it ever rise or does it just keep running? So the slope of this horizontal line is 0. So whenever you get, say, something has a slope of 0, that just means it's a horizontal line like this. Let's take a look at a vertical line. All right, let's find the slope of the line that contains the points 4, 2 and 4, 5. So x1, y1 will be 4, 2, and x2, y2 will be 4, 5. Well, plugging it in, you get 5 minus 2, which is 3. 4 minus 4 is 0. Well, wait a second, can you divide anything by 0? Like if you plug 3 divided by 0 in your calculator, it'll say something like syntax error. All right, so this is what we call undefined. All right, mathematically it's not defined. So when you have an undefined slope, all right, that is a slope of a vertical line. Like rise, it always rises, but then it never runs. Okay, It rises here 3 units, but doesn't run any units. So this is an undefined slope. All right, so a horizontal line, like I said, always has slope equal to 0. So it'll always be like this. Lines like this has slope 0. Vertical line always has an undefined slope, and it'll always look like this. Now let's talk about parallel lines now. Parallel lines that are lines in the same plane that do not intersect. So L1 and L2 are examples of parallel lines. They just go on forever in the same direction, but they will never cross. Okay, so let's take these two parallel lines here and find their slopes. Like what's unique about their slopes that make it so they never cross? Well, for both lines, if you look at it, you can do this on your own, find any points. If the run is 3, the rise is 1. So if you take this point here, you go 1, 2, 3, you go up 1. Take this point here, go 1, 2, 3, go up 1, right? So the slope of both lines in this case is rise over run, which is 1 divided by 3. So it looks like these lines that are parallel that never cross have the same slope. So it makes sense that non-vertical parallel lines have equal slopes, since the parallel lines have to have the same steepness for them to never cross. Right? If their slopes were not equal, they would eventually cross. All right, so if L1 and L2 are non-vertical parallel lines on the same coordinate system, then the slope of these lines are equal, right? Where M1 is equal to M2. Also, if two distinct lines have an equal slope, then the lines are parallel. Okay, so it works both ways. So if they're parallel, slopes are equal. If their slopes are equal, they're parallel. All right, let's talk about perpendicular now. Two lines are called perpendicular if they intersect, and the way they intersect very specifically has to form a 90-degree angle. Okay, so if L1 and L2 intersect and we have a 90-degree angle here, boom, they're perpendicular. All right, let's take a look at this. All right, let's see what we notice. Let's find the slopes of the perpendicular lines L1 and L2. All right, for L1, we can see that the slope is 2, 3, right? Meaning, let me find L1 here. All right, if I go rise 2, 1, 2, then I have to run 3, 1, 2, 3. Yeah, that works out. So the slope of M1 is 2, 3. Now looking at L2, all right, let's pick a point on the line here for L2, right here. The rise is -3, so I'd go down 1, 2, 3, and then I'd run 2, 1, 2. All right, so the slope here is -3/2. Check this out. The lines are parallel, or excuse me, perpendicular. But the slope of this one is 2/3. The perpendicular line to it looks like it's the flip of this. So it goes from 2/3 to 3/2. This was positive and this is negative. That's interesting. All right, so if L1 and L2 are non-vertical parallel lines, then the slope of one line is the opposite of the reciprocal. So when I say opposite, it means signs change of the slope of the other line. So M2 is equal to, if M2 is the slope of one of the lines, is equal to -1 divided by the slope of the first line, right? So also, if the slope of one line is the opposite of the reciprocal of the other line slope, then the lines are perpendicular. Works both ways. Let me give you an example here, okay? Suppose you have this one line, L1, has slope 3, 7. Suppose you have this other line, L2. If L2 is parallel to L1, find the slope of L2. All right, so remember, I know L1 is 3/7. So what is the slope of this parallel line, L2? Well, the slopes of L2 and L1 are equal because if they're parallel. So line L2 also has a slope of 3/7. All right, this other line, L3. Suppose this line 3 is perpendicular to L1. Okay, we know L1 has slope 3/7. So find the slope of the perpendicular line. Well, the slope of the perpendicular line is the opposite of the reciprocal. So you take 3/7, you flip it, it becomes 7/3. Since it was positive, you would then make it negative. And the slope of the perpendicular line here is -7/3.